Assalamualaikum. Hello everyone, welcome back to my channel. Today I am here with the continuation of exercise 15.1. In my previous video I have completed till problem number 3. So let us see the question number 4 of exercise 15 point of surface area and volume. Here let me read out the question. A cubical block of side 7 cm is surmounted by a hemisphere. What is the greatest diameter the hemisphere can have? Find the surface area of the solid. What they have told? A cubical block of side 7 cm is surmounted by a hemisphere. For example, this is a cubical block and on that hemisphere is surmounted. What is the greatest diameter the hemisphere can have? Find the surface area of solid. Here, for example, I'll just show you here. This is, for example, one cubical block. I've just taken one small box. It's like a small cubical block. Okay. On that, if we surmount one hemisphere, I have taken this small hemispherical shape. This, if we just completely surmount this on this cubical block, then we can see this, the shape which formed is the given question shape. Now we can see that this completely upper surface of the cubical block is covered by this hemisphere, right? Now find the surface area of the solid. So surface area of solid, how can we find? Total surface area of cube minus this surface, because it will not see which surface we can touch, that surface area we should find. Now we can touch this side, this side, this side, but we can't touch this side. This side will covered with the hemisphere. So here we should minus this part. Which part? This circular part should be minus, where the hemisphere will be surmounted. This part we should remove. See, here the hemisphere is surmounted. Now hemisphere is surmounted is nothing but completely. What is the bigger diameter? Bigger diameter, greater diameter is nothing but the side of the square, cube. Completely side of the, it will completely surmounted on the cube. Hemisphere is completely surmounted on the cube. So the greatest diameter of the hemisphere is nothing but side of the cube. So what? So the figure is in this form. Now let me start solving here. The hemisphere can occupy the whole. Here the hemisphere, to solve this problem, first we have to understand the figure, what they have given, how to find, which area we should find. That is very important. Here the hemisphere can occupy whole of the side of the cube. Whole of the side of the cube. Okay, now let us see the so the diameter of hemisphere is equals to, therefore diameter of hemisphere is equal to side of cube. Side of cube is nothing but 7 cm. It is given a cubical block of side 7 cm. Therefore, the greatest diameter, what they have told, what is the greatest diameter? Therefore, the greatest diameter is 7 cm. Greatest diameter is nothing but 7 cm. Okay, side of this. Now let us start finding the surface area. Find the surface area of solid. Surface area of solid is equals to, surface area of solid is equals to TSA of cube minus, from TSA of cube what we have to find? Base area of base area of hemisphere plus CSA of hemisphere. Which area we can touch, that all area we have to write. Okay, just this area we should remove. Then TSA of cuboid, TSA of cube and CSA of hemisphere. Now TSA of cube is nothing but 6 side square. 6 into side square minus base area of hemisphere is nothing but base area of hemisphere is what? Circle. We can see base area of hemisphere is circle. It is nothing but area of circle is pi r square plus CSA of hemisphere is nothing but 2 pi r square. We should know the formula well. 6 side square is nothing but given side of a cube is 7 centimeters, 7 square minus 2 pi r square minus pi r square. See, nothing means 1. From 2 pi r square, if we remove 1 pi r square, it is nothing but greater number is plus. So, plus pi r square. Okay. 6 into 7 square is 49. Plus pi value is 22 by 7. Into r is, if the diameter is 7, then radius is 7 by 2. If the diameter is 7, then the radius is half of the diameter. So 7 by 2 into 7 by 2. 2 times. Why? Because r square it is. Okay. So let me multiply this here. 49 into 6. 6 9s are 54. 6 4s are 24, 25, 26, 27, 28, 29. 294. Plus 7 7 get cancelled. 2 1s are 2, 2 11s are 22. So 11 7s are 77 by 2. Now this 2 we should multiply here. 2 4s are 8, 2 9s are 18, 2 2s are 4, 5. 558 plus 7 77 upon 2. Now 588 plus 77, if we add, we are going to get 665 by 2. So if we do 665 divide by 2, how will get 665 divide by 2? 2 3s are 6, 6 bring down, 2 3s are 6, again 5 you have to bring down, 2 2s are 4, 1 remains. Now 1 is smaller than 2.0, 2 5s are 10. So we got here 332.5. It is in centimeters, so centimeter square. So this is the answer for the question number 4. How we have to minus the base area and we have to add the remaining part. Okay, let us see the next question. This is also exactly similar like this question, but this is very important question. Okay, a hemispherical depression is cut out from one face of the cubical wooden block. Okay, such that the diameter L of the hemisphere is equal to the edge of the cube. Determine the surface area of remaining solid. Exactly same which we have done previous problem. It is exactly same like fourth one problem, but here there we have just surmounted the hemisphere, but here we have a hemispherical depression is cut off. For example, a wooden box. From that wooden box, hemispherical part of complete the whole cube is removed off. For example, you have seen ice cream box, complete full ice cream box. From that, a scoop of ice cream is removed. That is full diameter here to here. For example, same figure I'll just show you here. It is in this form. For example, if we complete a ice cream scoop, hemispherical ice cream scoop is removed. full hemispherical ice cream scoop is removed and the diameter is equal to the side of the square. Same like previous problem, there surmounted, here here removed. So let us determine the surface area of remaining solid. Exactly same. Here we have to cut off the hemispherical part. Okay. So let us write here the diameter of hemisphere is equal to side of the cube. It is told in the question. And both are equal to L. It is given L. Diameter L. Okay. So now directly we should find surface area of solid. Surface area of remaining solid after cutting the scoop, like remaining solid is equal to same formula like surface area of cube minus, from total surface area of cube we have to minus base area of hemisphere plus CSA of hemisphere. Three things we have to do. Okay. Total surface area of cube is 6 into side square minus base area of hemisphere is pi r square. That is base area of hemisphere is circle. Area of circle pi r square plus CSA of hemisphere is 2 pi r square. Okay. Now 6 side square. Side is L minus 2 pi r square from 1 pi r square. If we remove pi r square, but greater sign is plus, so plus pi r square is left. Okay, 6L square plus, let us keep pi as it is. Okay, according to textbook answer we should keep pi as it is. R is L by 2 because if diameter is L, radius is half of the diameter. So if diameter is L, radius will be L by 2. Okay. So here 2 6 first let us 6 L square plus pi L square as it is. 2 square is nothing but 4. Okay. 6 4s are 24 L square plus pi L square upon 4. Let us write 1 by 4 outside, that is 1 by 4. L square is common. What is left? 24 plus pi. This is the answer of surface area of remaining solid. This is how we have to find out the problems. Here we should understand the figure first and we should know how to remove, what we have to remove and what we have to add. Okay. Let us see the question number 6 now, which is a very important question. Here I have not drawn anything. You people have seen a medicine capsule. So think on that. A medicine capsule is in the shape of cylinder with two hemispheres stuck to each other of its end. The length of the entire capsule is 14 mm and the diameter of the capsule is 5 mm. Find its surface area. Let me draw one capsule like it is what they have told. They have told in the question a medicine capsule is in the shape of cylinder. Okay, let me draw one cylinder like this is the cylinder. A medicine capsule is in the form of cylinder with two hemispheres stuck to each other. With two hemispheres stuck to each other. Like this, a capsule shape is they have given. Okay, now they have told here two hemispheres is stuck to each other, each ends. The length of the entire capsule is 14 mm. full capsule length is 14 mm and the diameter of the capsule is 5 mm. Here the diameter of the capsule is nothing but 5 mm. Okay. Now what we need to find, how we can find the find surface area of capsule. How we'll get the surface area of capsule? Surface area of capsule is equals to surface area CSA of cylinder plus what we have to find? CSA of cylinder plus how many hemisphere? 2 hemisphere. 2 into CSA of hemisphere. Why CSA? We can only outer part. We are taking only CSA of cylinder and CSA of hemisphere. Okay. Now in CSA of cylinder, we know the formula is pi r square h. So here h, height of the cylinder we don't have. They have given diameter 5 mm and total height they have given like total height it is given 14 mm. Now cylinder height, how we will get? See, we know that if this is the diameter, radius is nothing but 5 by 2. If diameter is 5, radius is 5 by 2. We know this. And I have told in previous problems also that radius is equal to the height of the sphere. This also is radius. And this side also is radius. So, sphere height is nothing but radius of the sphere. Now, 2 sphere we have to remove to get the height of the cylinder. How we will get height of the cylinder? Height of cylinder is equal to total height minus total height, full total 14 minus these 2 hemisphere we have to remove. That is radius. 2 into hemisphere radius is 5 by 2. This much we have to remove. 2 radius we have to remove. From total length 14 mm, 2 radius we have to remove because 2 hemisphere. Radius of hemisphere is equals to height of the hemisphere. So, 2 get cancel. 14 minus 5, that is equals to 9. Now we get the height of the cylinder here. So, now 9 mm we got the height of the cylinder. Let us solve a problem. Surface area of capsule is equals to CSA of cylinder. CSA of cylinder is nothing but 2 pi r h. 2 pi r h plus sign as it is 2 into CSA of hemisphere is 2 pi r square. Formula we should remember well. Now here we can see that 2 radius is same. Cylinder radius is also same as hemisphere radius. They both have the same radius. So let us take common. 2 common we can take, pi common we can take, r common we can take. 2 common, pi common and r common. If we have taken 2 pi r common, what left? H left. H. This side 2 common, pi common and 1 r common. 1 2 is here only and 1 r will left here. 1 r. Why? 2 pi r is common. 1 2 is left out and 1 r is left out. Okay, let us substitute the value. 2 into 22 by 7. Pi value is 22 by 7. R value is 5 by 2 into H value just now we have find height of the cylinder 9 plus 2 into R is nothing but 5 by 2. Okay. So here what we get, 2 get cancel here. Okay. 5 2s are 10. 5 2s are 10, 11. 22 5s are 110 it is. Okay. Here, inside the bracket, 2 get cancelled. 9 plus 5. Okay. 110 into 9 plus 5 is nothing but 14. 110 by 7 is there, is it? 22 5 is 110 by 7. I forgot to write. Okay. 110 by 7 into 14. 9 plus 5, 14. Now we can cancel here. 7 1s are 7. 7 2s are 14. So what we get answer? 110 2s are 11 2s are 22. 220 centimeters square. It's a very important question, very repeated question in the exam. Surface area of capsule, what we got? 220 centimeters square. So in my next video, I am going to continue from problem number 7. Do like and share and subscribe my channel. Thank you.